Okay, so we will discuss the ACES workflow and see why it's an opportunity for color grading and color consistency. So we will discuss the current color workflows in industry and the challenges that come with them. We will discuss the ACES concepts and the ACES components, and we'll then have a demo of the ACES implementation in Scratch driven by Graham. So about the workflows, any project goes through these different steps. On set now, more and more, since we have a clean SDI output from the camera, people might want to actually do some on-set grading, which is fine, because actually it can be a very good idea to show the director, the DOP, the agency, something that looks like the final product. The problem there is making sure that you are capable of carrying the information through the whole process. So if you just create lookup tables, that will be a challenge because you might have some very different systems that won't be capable of loading that lookup table. And if you use metadata like the ASC CDL, color decision list, you also need to make sure that this information translates well through the different systems. When doing the dailies from the rushes for the offline editing, you bake a look, and again you need to make sure that this look can carry through. During your offline, obviously, well, in general you don't have a proper display there, but that's the place where in most cases people spend the most time, and people get used to that picture, but there's not much you can do about it. During the visual effects process, then it's a big challenge because you have a lot of different systems interacting, and it's kind of a challenge to interrupt between all those and carry the information through. Also a lot of different display technologies. So obviously when you get to the grading stage, you are the place where you have proper monitoring, but you have to make all the different problems that came before to fix them and make everything look the same. When you're happy with your grading in your mastering room, then you need to make sure that this translates well into your deliverables. So when it's video and tape, it's pretty easy, but when you have to deliver files, then it can be a much more of a problem, and the film out, even though there is less and less, film out is also a big challenge for colors. So different types of workflow and signals. Something that is, I would say, the legacy, the first one, at least in digital, is the video signal, which has been designed to be perceptually linear. Perceptually linear means that, in fact, what you see on your TV looks like how it was shot with the camera. The thing is that it's only perceptually linear, so it means that on the right you can see we have on the bottom we have a typical response of a CRT monitor, so it has this power curve. So to compensate for this power curve, we need to have this inverse power curve to pre-compensate the signal, and the resulting picture is something that is linear. So we have this concept of gamma in here. It's pretty easy, especially if you're in a full video environment with VTRs, tapes, and CRT monitors. But obviously now, since we don't have CRT anymore, it becomes a challenge because we have new display technologies that are not behaving like a CRT technology, and so can be problematic just to show the right colors. The telecine workflow is technically, a telecine is a converter that takes the original negative and makes that into a video signal. So obviously, it removes a lot of the film dynamic range, and it has to be creative because you need to make sure that you throw away the signal and get something that is nice. But considering again that you've really removed a lot of the information, especially in the highlights, and so that is a creative tool that just bakes your look. Something to actually preserve the whole dynamic range as opposed to the telecine workflow where you reduce this dynamic range. The DI workflow is designed to be transparent if no correction is applied. It means that you scan the original negative, you make a digital representation of this, which is generally a Cineon file, and if you don't make any correction, it should look exactly the same as if it was going through the analog process. So it keeps the whole dynamic range, but to see it the way it will look at the end, we need to use film print emulation that actually replicates the way the lab processes the color. So the reference in here is still the output. We monitor the signal with an emulation of the output of the lab, but we keep the dynamic range from the original negative. When working with an EXR workflow, high dynamic range workflow, it's called a scene refill workflow, in the sense that we don't care about the output. We actually measure the dynamic range of the actual scene. So in that case, in most cases, you won't have any gamma. We're working with a truly linear transfer function. And we also use floating point to store the whole dynamic range. The problem with that is that primaries are not defined. So just a quick sum up about primaries and gamut. Color spaces are defined by the white point, the transfer function, and the primaries. So on this triangle, you have for the red, the green, and blue, the primaries. So you're pretty used to that diagram, because every time you buy a display or see something on the web about display, it shows that diagram. Actually, in most workflows until now, we don't really manage the primaries because they were pretty easy to match together. Now that we have a new type of sources that can make things much more different, it's actually a much bigger challenge to make sure things look the same, especially with high dynamic range cameras and imagery. So for example, with digital cinema cameras, like the Red or the Arri Alexa, we have, with the Red, we have a lot of different mappings. So on one side, we have the transfer function with the red gamma 1, 2, 3, 4, red log film. And then we have the gamut. So that's where we actually map the original camera primaries to another color space that will be our working color space within the grading or the visual effects application. So we have different choices, and sometimes it can be a bit of a challenge to find something that works. And every vendor and every manufacturer has its own way of mapping data. So you get the raw signal from the camera in the raw file, but when it gets to be translated, you have different choices, and it's even a bigger challenge when you have to mix different types of content within the same timeline. So the proposition from the Academy of Motion Picture is to actually first draw a color space that has a very, very wide gamut. So as you can see on this diagram, we have negative values actually for the blue, and technically with the red and green, we have values, especially for the green, we have values that go beyond the visible locus. So the visible locus is this horseshoe. You can see that we have colors that are not visible in the ACES color space. So this is compared to in purple we have the SMT reference projector and the Rec 709 in green. So as you can see, it's a much wider gamut that is used for that. It uses floating point to store data, and really it's meant to make sure that any kind of signal being digitally acquired, film acquired, or digitally generated will go through without any clipping of the actual information. And it's meant to actually unify the color management across different facilities, different departments in one facility, and making sure that everything gets processed the same way. So you have consistency between sources and consistency between the displays. So the different components that are used in the ACES workflow are the IDTs. So the IDTs are input device transforms. They are provided by the camera manufacturers, and it makes the original camera space translate into the ACES color space, which means that, and that's something that is very important for you guys doing grading, because it means that you have something that should map the original colors into something that works, that gives you by default something that is right. So that is very important, because different cameras, and most of the shows we see today have different camera sources, and it's usually a bit of a challenge to actually know which parameters to start from and create the look from. That is something that here we'll take, for example, a red camera, a Sony camera, an ARRI camera, that will put all of them on, if they shoot the same scene, they will shoot the colors in the same place on the map. So that won't transform one camera into another camera. That's not the purpose of it. But the plan is really to make this process, I mean, you can spend quite a lot of time when trying to match different cameras, either in a compositing context or into a grading context. Now it gives you a starting point where all the cameras are set pretty much in something common. So that is for the input. Something that is important too is with the ADX, we also have management for the film until, again, with the DI workflow, we used to use the output color space, the film lab color space as the reference, and not really manage the input. In that case, actually everything is mapped to the ACES, meaning that there is a reverse engineering made of both the film scanner and the film scanner, the film stock and the film camera to get back the colors of the original scene. And on the other side, when you deliver ADX files to a lab, it's the lab that actually calibrates itself to the ACES to reproduce the most colors it's capable of. So that's also something that is very interesting, because you should have something. Your reference now is the ACES color space. It's no more your film output. On the output side of things, with the output device transform and the RRT. The RRT is the reference rendering transform, which is meant to convert the very high dynamic range of the ACES color space into something that is actually transportable, and then remapped with the ODT, the output device transform, to your display. So your display being, for example, digital cinema projector or an sRGB monitor, and also that could be used also for the outputs. You will bake those RRT plus ODT to get your final output, and RRT makes actually allows to have consistent displays, consistent rendering between different facilities, because also this concept of remapping a wide gamut to a smaller one is something that is really complex and used to be made very differently from one place to another. In here we have a standard way to do the thing. It doesn't mean that everybody will have the same look. Obviously not. The grading is still part of the process, and this actually can happen either in ACES or on other color space, but everything can connect through the ACES color space to be sure that at the end you have something that is fully compatible. So when you output an ACES file, these go through RRT. So why is that important? Is because now if we have a common ACES color space on set during visual effects for the dailies, for the grading, we know that, for example, basic transformations will mean the same thing everywhere, because that was always the problem. When you had, for example, a CDL-based workflow, ACES CDL standing for the color decision list, you had something that was actually heavily dependent on the viewing color space again in here, and also the working color space, which in general was the same. In here, since we have the same working color space, or we can translate this working color space to a common standard, we can also have translation of the transformation from one to the other. So have a way, for example, to create a look on set and have that to translate, even if you have a different viewing system. So for example, people would use Rec 709 on set, but would use Digital Cinema P3 in the grading room. You could have translations on this concept. So that is something the RRT won't fix. Won't make a perfect match between a P3 and an SR output and an sRGB output, but at least will give you something that is as far as is technically possible, because obviously, for example, if you work with a projector and you work with a monitor, there are some perception aspects that make it like that you will feel differently, even though the color could match very, very well. So those are very important concepts. The concept that actually ACES doesn't take is the fact that you will still have to calibrate your display to match the actual standards, being DCI-P3 for digital cinema projector or sRGB for monitor, but the ACES will render to those standards. So why is it something so important that we actually get the best of previous workflows? For example, we can get the whole dynamic range pretty much like as we had with DI from an original camera source. So that's something that is really, really interesting. We have also, as well, we have with EXR being the file format used to transport ACES information. It's scene referred, so actually we translate the scene referred concept into an actual a real scene capture, because the IDT takes the real colors from the real capture and map them to the ACES workflow. So that means that will really simplify the process for visual effects, because they will have access to the real colors. But what it means also for the colorist means that now you don't have to fix, creating a look is no more about starting from the original camera and not about fixing it to bring it back to where it should be and then build upon that to create a look. You start your look from something that is already balanced, that looks natural. The RT has some components that creates some kind of look that is meant to be pleasing. But the good thing is, since everything is consistent, you can really create a library of looks that then you can move to different sources, and they will all behave the same. So that's something that is very interesting, because you can really factorize all of these and make sure that this translates from one project to another. And also, since you have those looks and they will translate from one display to another, they will also translate from one system to another if you rely on standards like the CDL color decision list or the LMT, the look management transform. This should translate from one system to another, and so you will be able to carry your looks all across the production process. So this is extremely exciting, because we will have more and more tools to develop those looks, and actually working with more dynamic range also makes more opportunities to go into more advanced kind of look creation. So that is for the theory. Now it's time to take a look at how it looks in Scratch.